Welcome back. We're going to be looking at how we can take some really cool stuff inside our game that we've been working with, and so we can make it so we can actually handle the idea of collisions or things happening. Right now, when we just set up the game, when we attached the physics bodies last time, all we do is just when we drop something down, it falls down, it has a nice little physics effect, but that's it. What we want to do is we want to make sure we can actually detect when these collisions happen and make something happen because of those collisions. Right now, it simply just keeps on building it all up, and you can have this great little pile of blocks that just happen to grow randomly based on whatever blocks happen to drop on there. In order to do that, though, in order to actually handle those collisions themselves, to tell rather than simply just, oh, I've got a physical action of dropping an object down and it happening, I want to make sure something that happens because of the contact between these things. We have to go ahead and add a little bit of code to our project to keep on working with this. So again, we're going to go ahead and we're going to go over to our Xcode for the project. And again, notice again that when we're talking about this, when we're talking about all the logic and the stuff we're working with, we don't do anything inside the actual game view. So drop game view, it loads that scene like we did that very first video when we put together the actual application. And that's all the change we make the entire game. This thing just sits there and it doesn't get changed after we do that, because that's not what we need. We're actually doing the work. Where all the work again happens is inside our game scene itself. So in order to do this, let's go ahead and go to our game scene file. And let's go up here to the top. And let's take a look at what we have to have happen. So in order for this to actually do something inside our scene, we have to do a couple different pieces of code to make that happen. And so the first thing we have to do is we have to change our class header. The class header originally just had the inheriting from SK scene because that's what the game scene class does. But we have to add some information to that. The first thing we have to add is we have to add that we're going to conform to the SK physics contact delegate. The SK physics contact delegate is what allows physics contact to actually be handled inside the game. And so we say we're going to handle that by first adding that line right here. It's just another protocol. You can have as many protocols as you want. Some games will have a whole bunch of protocols they deal with, but this is the one we're working with right now inside our drop game. Then inside our did move to, our method where we do all the work, we have to go ahead and we have to tell that the physics world that the contact delegate is self. So this happens, of course, after the physics body has been assigned, because of course we have to have a physics body that we're handling just physics itself. That's part of just SK scene. And that's where we have just the, oh, I'm going to hold the blocks together. But actually handle the contact between those components, that's what this physics world.contact delegate. So we say, oh, this program right here, this file, that's what's talking about it. So this is the file that's going to handle all that contact. In order to go along with that contact, we've got a couple other pieces we have to work with. The next thing we want to look at is right here. You can see I have a private var called color mask. It's of type int, and I'm assigning it to 0b0000. So it's a binary mask value we're looking for, or bitmask is what we're doing. So it's going to be 0000 or 0. I know, crazy. But a bitmask is what that's coming down to. And we'll see how we use that here in just a minute. And so the bitmask, of course, we're going to talk about that, and we're going to assign the bitmask to the piece that we're working with here inside our touches began, where we do all of the work when we're attaching things to that. And that's with node.physicsBody. We unwrap it because we don't know the physics body actually exists, even though we created it right here. But just in case it doesn't, we have to do that. And then the contact test bitmask. This is specifically the type of, did this thing touch this thing? Was there contact? There's also a collision bitmask and stuff like that, but this is the contact test bitmask. So that's what we're looking for, and I'm assigning to it color mask. And the reason I call it color mask is, as you can see right here, when I set that current color, I want to assign the color and bitmask to it, because when we add that inside my assign color and bitmask, I go ahead and I grab it so right here, so I have my black, red, blue, green, whatever colors I put inside my appropriate list that I'm working with. I also want to assign my color mask to be random index +1. So I'm going to go up by 1 for that automatically, because I'm going to take out of that what I'm taking out of that list, but I want to shift it by 1, because if I assign 0 as my mask that I'm working for that, where I'm using that contact, it's just going to fall straight through the actual floor of the game, and I don't want that to happen. So that's why it starts off at 1, 2, 3, 4, whatever. So just as an FYI, that's why I'm not assigning 0. So all of my blacks will have 1, the reds will have 2, the blues will have 3, etc., all the way down the line. So for however many colors you're looking to work with, that's where that comes into play. So just FYI, that's where that's coming from. So we assign that color mask as, again, as part of the game. When the colors match, that's when we want to have the collisions itself happen. So we go ahead and we attach that bitmask right there, that color mask with it. And then I have this lovely method right here. I have my didBeginContact method. This is the method that actually does the work. I commented out so I could demonstrate that part for you just again in the game. So we'll take that comment out. And we can have right here, we have our collision between and our annihilate methods. And these are the methods that actually do all the work that we're working for when we're talking about the contact itself to happen. So the first one we have is the didBeginContact. This is the one that's part of the SK physics contact delegate. This is the one that fires when contact happens. So as the scene is running and executing, anytime nodes come into contact, this is going to happen. And so this is the one that gets fired by the game. We don't call this ourselves. There is no call to didBegin. So if I do Command F right here, and I do didBegin, There's only one call to it. It's right here. This one match is just because I actually defined the method. It's not called ever by us. It's called by the actual SK scene. This is one of those things that, again, so we're using SpriteKit. We're letting it do the heavy lifting for us, and so that's great. So we don't have to call that right here. This gets called automatically because we have the SK physics delegate, and we have that working for us. And what we do is we have to do two things first inside the first of the did begin. We first have to make sure that the nodes we're talking about actually still exist. The problem is when we have things contact each other, this versus this, or this versus this, or this versus this, or whatever we're talking about, we have those things happen, and they could be happening all the time, and they could happen at the same time. They contact each other. And so we have to make sure that when we do that, we don't have any ghost images, or excuse me, that we don't have any ghost sprites, because when we come back and actually do this, we want to make sure they do actually exist inside there. So we have a guardlet pattern that we're working with this. So guardlet first equals contact.bodyA.node else return, and guardlet second equals contact.bodyB.node else return. So say, for example, I already have taken something out and I try and come back and see it, that guard body B. If it's already been removed, I can't do anything. It won't cause a crash. So I already leave at that point. So this is a way to make sure I handle my code in advance, making sure I don't have any accidental double removals, which are called null pointer exceptions or badness. Ooh, sad. We don't want to crash our app. So we first make sure that we have something happen. Then, based on that, I call collision between first and second. So I have a method, collision between, which takes two nodes, the first and second nodes right here, and there's a collision that happened between the first node and the second node. I don't worry about the contact between the second and the first because that's not what we have to handle. We're just looking at that first contact right here. So then go to collision between. This is a method I wrote that's part of my app, and this is how I'm handling it. So I have private func collision between, and underscore node 1 is a SK node, and node 2 is SK node as well. So I'm using that naming convention with Swift, so we can have the exterior name versus the interior name, which allows this really cool call of collision between first and second, so I don't have to have an exterior variable name. I just use that parameter right there I just declared. And then when I come inside, it's called node 1 and node 2, because that way I can easily refer to the concepts inside that code and make a lot of sense. So then I ask, hey, is node 1, can I get its physics body? If so, let's go ahead and get its contact test bitmask. Let's grab that value. Let's also go to node 2. Can I get its physics body? If so, great. Let's get its contact bitmask. And if the contact test bitmasks between both of them match, aka the equals equals sign, then we're going to call annihilate. We're going to destroy them. I know, it's a little bit of fun, but that's okay. So I call annihilate to node 1, and I call annihilate dead node passing at node 2, because those are the dead nodes we're sending to it. So then I go down to annihilate. My annihilate method, as you can see, takes a dead node, which is an SK node. It just has that single exterior name because it works for both interior and exterior. It's a wonderful name. It's an SK node. And again, like all these others, they're void methods. I add my score. Okay, cool. And then I say my explosion effect. We'll take a look at that in another video. And then I say dead node.remove from parent. So what dead node.remove from parent does is it says, hey, node, we don't want you in the game anymore. We don't want you to lag it down, make it go so slow because it's not being used anymore. So we make sure we take that node out of the tree. We remove it from its parent. And so boom, it's out. It's no longer going to be counted as the amount of active nodes. It's not going to be anything that we can have to slow our game down or any problems like that. And so this would also be a great way we could have some cool other effects by, say, for example, if there's some, we want to make it so if the node count gets to a certain point, we can end the game, et cetera, yada, yada. But by removing it from the parent, the node is out. It's no longer going to be part of the animation. It's not going to be costing the memory or the application itself any more time. And so we can have that out of the way. And so we have that annihilate method that takes it out of the game and makes it so we can then move on. And so that happens all because of this, all these actions happen because of did begin. Now, when I actually write this stuff, I wrote the annihilate method first, then I wrote collision between, and then finally I wrote did begin, because that way when I write my actual functions for this, my functions always compile and work just fine, because this one doesn't call anything else, and then I can call this one, which calls the annihilate method, which then calls by did begin, so I can make sure my code is compiled well. And again, you can take a look at that in the instructions for the actual video itself, but that's how we can build this up and make it so we can have contact happen between that. There's other types of contact you can do. Take a look at some of the other videos or tutorials that are out there on how you can use SpriteKit to do some really cool games. But again, to make contact happen, we have to first go ahead and give it so that we have a SK physics contact delegate. The file needs to know what's going on. We need to give it a bitmask we have to work with so we can know what contact we're happening. We have to make sure that we assign the physics world contact delegate to be self, so that this file is the one that's handling all of that contact. It knows that that's where the did begin contact is going to exist. We then have those three methods for the did begin, which calls collision between, which calls the annihilate method, and does that work. And so that's how we can have collision happen inside the game. And now that I've uncommented out that did begin, I rerun my application. And when I click on it, if the colors match, get something matching here. Of course, no. There. Oh, boom. The colors match, the two hit and they annihilate. They take each other out. And so that's what happens because that did begin contact happened. It then called the collision between. It checked to make sure those colors match. That's what the bitmask does right there. Then it called the Annihilate method, which then went overhead and set the score to go up by 10 each. Called the explosion effect, that cool little poof we saw, and then told each of them to remove themselves from the parent. Really cool effect, great thing to do, and that's a great way you can add some fun and functionality to your code. Thanks again, and have a great day. We'll see you next time. Cheers.